Mr. Danahauer here. Today we are going to learn a few new features in Onshape. Today we're going to be building what's called a servo mount, and this is a small housing for a servo motor. This is what a servo motor looks like if you haven't seen one before. They're very common in small electrical applications. These are basically little motors that you can hook up to an Arduino board and control the direction and amount degrees of rotation on these servos. So these are very common, and oftentimes we want to have some place to put them so that we can mount them to projects and whatnot. This will be a fairly simple project. We're going to use a couple of new features, including shell, and we'll also use a mirroring feature. We'll also create a face blend here where we can strengthen these tabs. Anytime we have an overhang like that, it's nice to have a little extra material. And for me, I'm thinking of 3D printing this, and so doing some kind of additive manufacturing. And I like that little extra support that this would provide with this face blend. So those are some new features we'll learn today. Okay, let's go ahead and get into a new document. So I'm going to go to my Onshape dashboard and do create document. And we'll title this servo mount. All right, you can call it whatever you'd like. And that's going to open up our document workspace. Now, before we start, anytime you're CADing, it's really important to know what your measurements are going to be. Now, if you're just CADing something for fun and it's not a functional object, then you probably don't need to worry too much about the size of things. But because this item, this servo mount that we're going to create, needs to fit this servo motor precisely, we're going to need to look up the measurements for this particular servo that we're making the mount for, or we're going to have to actually measure it. Now, this is a very common, this SG90 is a very common servo, and we use them all the time. And so I was able to pull up a spec sheet. That's what we call a sheet, just has all the information of the servo on it. And I pulled this up and it gives me the dimensions that I need. Now, let's say I couldn't find this, what would I do? Well, I would pull out my handy digital calipers and start to write some measurements down. And I would probably just sketch this out on a piece of paper. That's normally what I do, and write my dimensions down. And from there, I can create my design based on those dimensions. We want this to fit nice and cleanly, snug into that mount. And we want these tabs right here to fit on the tabs that we're going to screw the servo into. And so those are some things to consider. If you haven't ever designed something before that you're, let's just say 3D printing, like I'm thinking with this one, you really need to practice that a little bit, because having precise measurements for different components to fit together is extremely important when it comes to designing actual parts. So I have got my spec sheet here, and we're going to refer back to this. Let's review a couple of the skills. I'm going to click on my top plane here and hit end, view normal 2, because I'm going to sketch on my top plane. And I'm going to come over to the visibility here and turn off my front plane and my right plane. Now, also remember, if you've selected something and you want to deselect it, spacebar will deselect anything that you want to. So we're always going to start with a sketch. I need to think about, how big do I want this box to be? I'm going to create my sketch, which is going to be a 2-dimensional rectangle, and then I'm going to extrude that sketch. We're going to use a new feature called shelling, which is basically hollows something out. And so we'll get to that in just a minute. But let's go ahead and get started here, and I want to get some measurements. So let's just start off here. I know that I want my box to be at least, B here is 23 millimeters and D is 12 millimeters. So I want it to be 23 by 12. All right, I'm going to use my sketch function. I'm going to sketch on the top plane, and I'm going to come here and do my center point rectangle so everything is centered. Remember, we want to snap to points, and so that we can fix our rectangle here. And I'm just going to go ahead and click on that. And again, you can see that down here, this box is whited out. That means it's ready for dimensions. And I'll come back here and check one more time. So 23 by 12. So I'll go ahead and hover over this one, 23 by 12. And I'm just typing these on my keyboard. All right. Again, this should be in millimeters just based on the size and my experience with this, but I'm going to come and check and make sure that my workspace units are in fact in millimeters, and they are. So we're good to go there. If you needed to change that, that's very easy to do. So now we have this dimensioned. Um, and we're going to go ahead and extrude this. I want to think about this really quick. So I need the depth to come up to these tabs right here. So this distance F is what I'm looking at, and that says 19.5 millimeters. So let's go ahead. We've accepted that sketch. Let's go ahead and extrude this box, and I'm going to go 19.5, and it's already in millimeters, so I can just hit enter. And when I rotate this by left clicking and dragging, you can see it has extruded this box out. Okay. All right. Now we have the framework here. Now the shell feature allows us to click a face like here and actually hollow out through there and insert a dimension for the width of the walls. And the shell feature is right here. So we've accepted sketch one, we've extruded that, and now we're going to come to the shell feature. And this is going to ask, what face do you want to actually have a hole? Like, where do you want to hollow it from? Where do you want the opening to be? So I'll just click on the top here. And then it asks me for the shell thickness. Now for this would be something that is a good thing for 3D printing, is how thick should your walls be? I have printed some examples of 0.5, 1 millimeter, 1.5, 2 millimeter walls so that I can refer to that and decide how thick I want it to be. When you do this a lot, you'll kind of get used to it. We're going to go ahead and just do a 2 millimeter wall thickness here. All right. Now, this presents a problem because this is hollowing out from the outside edge. So my object, my servo, is actually not going to fit in here. So this is one of the reasons why, let's go ahead and accept this for now. This is one of the reasons why it's important to plan ahead and kind of think through your design. I'm going to have to go back and redimension this, all three sides, because I did not consider the extra 2 millimeter wall thickness for each dimension. All right, so let's go ahead and do that. The nice thing is, if we make any changes to sketch one or extrude one, those are actually going to just carry out into the shell feature, and we won't need to redo any of that. So because in sketch one, my box, let's hit N for view normal 2. Okay. Remember that I want the opening of this to be 12 and the opening to be 23. And when I shelled this, I have 2 millimeter wall on this side and 2 millimeter wall on this side. So really this, I need to add 4 millimeters to this, and I double clicked on it to open it again. So 12 plus 4 gives me 16. Okay. And the same thing here. I'm going to have a 2 millimeter wall on each side. And so I'm going to add 4 millimeters total here for a total of 27. Enter. Okay. Now, when we accept this, watch what happens. All right. Now I can actually come down here and measure. So show measure details. I can click from this edge to this edge, and it will show me that's 27 millimeters. Okay. And if I do that again, I can do the inside edges. So, oops, let's get rid of that. If I click my space bar again to get rid of that, and I click here and click here, hopefully that's 23 millimeters. All right, good. You can always measure things after you've drawn it. Just come in and click on edges, and it'll show you distances down here. Now, there's still a problem with this, okay? And when you start 3D printing, you'll realize that you can't make things exactly the same size as you want them to fit together. I don't know if that makes sense, but let me explain. So the base of this BD, okay, is 23 by 12. When I 3D print this actual mount, the servo will not fit in this hole. It's not going to fit. How do I know that? Because from experience, I know that we have to include tolerances in our 3D prints when objects need to fit together. A tolerance is basically a little extra space that will allow for things to fit together. Now, A lot of people will say 0.5 millimeters is enough. And I know from the printer that I'm using, a Prusa, that if I do zero point 0.3 to zero point 0.5 millimeters is about right for tolerances. So just to be safe, I want this to fit snug. And the nice thing about 3D printing is I could easily print another one if I was just a little bit off. But let's go ahead and add in both dimensions. In sketch one, I'm going to add, let's go with zero point 0.4 millimeters extra so that we have the tolerance included. Okay, so we're going to go 16.4 and 27.4. Okay. And again, if you're using a different 3D printer, your tolerances might be different. This is the importance of learning and practicing with your 3D printer and paying attention to, does zero point 0.1 or zero point 0.2 millimeters matter whenever you're adding these tolerances. Okay, so this is going to fix our size here. Let's go in and measure this again. For that, I want to go to the center and the center here, and 23.4 millimeters. Okay. And spacebar again, and let's check this side and measurements. Make sure you're paying attention to what you're clicking on there. Those are the distances I want, 12.4. That should be just right, because I know that gives me 0.4 millimeters, which is just a little bit in each direction. Now spacebar. Now we need to go fix our extrude. So the extrude, we didn't pay attention to any of that either. We had 19.5. But I want this to go, I'm going to have my bottom, sorry, my bottom layer here is with the shell is going to be is going to be 2 millimeters. So I need to add that here. So I'm 19.5. So let's double click on that and go 21.5. Uh, and then again, I want that servo to slide down into the hole, but I don't want it to interfere in the bottom. And so I'm actually going to go ahead and add just a little bit more depth here, because I want the tabs to sit flush and I don't want them, the touching on the bottom, to interfere. So I'm actually going to bump this up to 22 millimeters. Okay. All right. So now again, when the servo slides down in here, it won't touch the bottom. But whenever I add these tabs over here, I want the tabs to sit nice and flush against there so I can screw them on. All right, good. So we have a start here, and we've learned how to use the shell feature. It's very easy, and if I decided I needed to change the shell thickness, I could do that in here. Although, keep in mind, if you change the shell thickness, then you're going to have to go in and change your other dimensions. Another way we might do this process is after we do extrude one, all right, instead of using the shell feature, we could create a new sketch on this, the top plane or the bottom plane, and extrude remove that. So there are again, there are many ways that you can CAD these different designs, and some ways are more efficient than others. Just depends on what you do. But I will tell you, the more of these tools that you know how to use, the more efficient you will become at CADing things. All right, what should we do next? Now, whenever we slide the servo into the mount, there's not going to be anything to grab onto very easily to pull it out. And so this is a nice little feature to add. We're going to rotate to the bottom, click here, view normal with the N on the keyboard, and I'm going to create a new sketch on the bottom here. So face of extrude one, and I'm going to create a small circle right here. And this is basically a push through circle. So I did a center point circle. I don't really care how big it is. All I want to be able to do is stick the tip of a pencil in there and push my servo out in case it's really tight. If you've ever done this before and you haven't included a push hole, you know how frustrating it can be to try to pry that thing out of there. Okay, let's accept that. And now we're going to go ahead and extrude remove to make the hole. So we do solid remove. We come in here. What face do we want to remove? And we're going to click on this circle, and I'm just going to go through all. Okay, and that's going to make my hole in the bottom. Perfect. And again, as I told you before, merge with all is a good thing for now. Really what you want to pay attention to is if you're just making one part and you end up down here on the parts list with more than one part, then you need to pay attention to the merge with all, because you probably didn't connect things when you were extruding things. So just an important tip. All right, so we got our stuff here. Now, the next part is I want to add my tabs to the side. And so I want those to just be on this face here. So I'm going to click on this and view normal. Oops, let's rotate that around here. All right. Those tabs, I want them to be a little bit thicker. So I want them to be 3 millimeters thick because they're going to be holding on to things. And they're basically just going to be a rectangle drawn on this face. So let's go ahead and create a sketch on this face. We're going to do a corner rectangle so I can snap to this corner right here. Remember, it's important to connect things. So this is like saying I'm attaching that to that corner so it doesn't go anywhere. And I'll go ahead and make sure that it snaps to this edge. And I'm going to go ahead and change this dimension, like I said, to 3 millimeters. So it'll be a nice thick tab. It may be a little bit of overkill, but that'll work just fine. All right, so we're going to accept that sketch, and now we're going to extrude this out. And I need to go check over here and see how far these tabs stick out. So E says 32 millimeters. B, my base width here is 23 millimeters. So these tabs stick out about 4.5 millimeters from the edge here. And so because of that, I'm going to go ahead and extrude these out about 5 millimeters. So let's go ahead and guys, just so you know, I paused for a second because I wanted to sketch a couple of things out on my paper, my scratch paper, and make sure I'm putting the right measurements on here. It's a lot easier to do that and do your rough sketches on a piece of paper, and then come and actually do your dimension stuff. So let's go ahead and come here and extrude. I'm going to extrude this tab right here, and it wants to go 25, and I actually just want to go 5 on that. And that looks about right. Okay, good. All right. Let's go ahead and accept that sketch. Now we've done that to one side. Let's go ahead and do it to this side over here. Now, there's a couple of ways we could do this. We could mirror that piece, but I'm going to hold off on mirroring those pieces, the tabs, and this is super easy. So we'll just do another sketch here, and do our corner rectangle. We match those sides, and this is going to be, let's escape. Oh, I missed that. So let's use our dimension tool, and I'm going to make this 3. Okay. And let's go ahead and accept that, and we'll extrude this piece right here. And we said we wanted to do 5 millimeters. Okay. So now we are starting to see something good here. We have our opening, we have our tabs right here. And again, remember, I added those together. So if for some reason down here you had part 2 and 3, it means it didn't merge those pieces together and whenever you extruded them. So it is important up here, instead of doing new, I did add, and that kind of merges. But if it didn't merge, you could click merge with all, and that'll take care of that as well. All right, now we have a couple of holes to put on here. Actually, let's do our face blends first, and then we'll do our holes last. So when we're doing a face blend, that is basically, let me get to where we can see this. All right, remember, if you can't, I'm not in the center here, so I'm going to hit Control on my keyboard. I'm going to right click and drag and recenter this thing. All right. Now what I want to do is face blend this, and we're going to go up here to this fillet tool, and I'll show you really fast. Fillets make like rounded edges. So if I wanted to make, for some reason, I wanted to make this edge rounded, I could use the fillet and click on that, and it's going to create this rounded edge. Now, I don't want to do that, but I wanted to show you what the fillet is because it's a very handy tool. It makes the edges kind of nice. So I'm going to cancel that. But under our fillet tool, there's also the face blend, and that's where we're going to join 2 edges that are at 90 degrees with a curved surface to strengthen it. So we'll do face blend. Now this one's a little tricky. It says side 1, so we're going to click this side, and then you have to come up here and go to side 2 and click that side. All right. And now you can see it's adding this curve, and you can come in here and change a bunch of stuff. Like if I wanted thicker, I could change the radius to 3. And it's really going to put a lot there. That's unnecessary for what we're doing here. And so I don't even think we really need 3. We'll just stick with 2 millimeter radius, and that's probably good. So that gives us a nice face blend right there. And that's really going to make this corner a lot stronger. If we're pushing on this tab at all, it's going to keep it from breaking. Let's come in here and do the same thing. And again, you can see all the things I've been doing. My tree of activities is all right here. So if I need to go back in and change anything, then I can. So let's go ahead and face blend this as well. So click on our first face, click up here, click on the second face, and accept that. All right, so now we have our nice strong corners with that face blend. One more thing you'll notice, these servos, they have a wire harness that comes off of them. So if I can figure out how to use my computer. And we need to have a slot for that. We can't, if you don't have a slot for those to go through, you're going to end up drilling a hole later, and that's frustrating. There's nothing worse than having to go drill out your nicely printed 3D parts. So honestly, I don't really care where this hole is. I just know that it needs to be big enough to fit this wire harness through. And I don't have any specs on that, so I could measure it, but it's not very wide. And I know if I put in about a 4 millimeter hole, that thing will fit through there. If I wanted to be precise, super precise, I could go in and adjust that. But let's pick a side, view normal 2, and I'm going to do a sketch on this plane here, face of extrude 1. And really all I'm going to do is create a corner rectangle. And honestly, I don't care a whole lot where it's at. And so I'm just going to click a spot and make an opening here for that wire harness to go through. Okay. And like I said, 4 millimeters would be plenty. This is going to be plenty big enough for that to fit through, but I could check it if I wanted to. Let's go ahead and accept that. We're going to go ahead and extrude remove this. So I'll click on remove, and we don't want to go through the other side. So I don't want to click through all. I'm just going to keep it blind, and I'll just bump this back here so you can see it. One thing I don't want to make sure I do is that the wire harness kind of comes off of the servo close to the bottom. And so if I don't get this right, oops, I didn't go through far enough, did I? Let's go ahead and reopen extrude 5 and go all the way through. That's important. All right, so you'll notice there's this little bump right here. And actually, I'll show you, we can use this cross-section tool. So let me show you what that looks like. I'm going to view normal 2, and I'm going to come over here and do cross-section section view. And what that's going to let me do is kind of drag and show you what I'm talking about there. Okay. And all this does is toggle this on. If we need to turn it off, we can come in here and just turn off section view. But what I'm talking to you about is this little lip right here. So I don't know where those wires come off in the picture here. They're a little bit up from the base of the motor, the housing of the motor. So this is probably fine. But what I think I'll do is just bring the edge of this box down so it's really close to the edge to make sure that those wires don't interfere. So I'm going to click that and go ahead and we can actually work on this from here, so we can use that section view while we're messing with stuff. And what did I make this with? I made this with sketch 5. So I'm going to come in here, sketch 5, and I'm just going to grab a corner and drag it down a little bit further and accept that and take a look. That should be fine. Okay. So again, I'm not being really precise. When you're CADing things, it's important to know what measurements matter and what you can, not really worry too much about, but you have to pay attention to details on this. So that looks pretty good. I'm going to turn off the section view now, turn off section view. And now we have our wire harness pushed through there. Okay. All right. Now do pay attention. I was not picky on which side this went on, but you'll notice, all right, the servo is not symmetrical. So the wiring harness comes off of the shaft side right here, as opposed to the non-shaft side over here. And so if you really needed to orient this in the right way, and the wire harness needed to come out in a specific location, then you'd need to pay attention to that. Lots of little details. Okay, the last thing we're going to do here is add our holes. And honestly, I don't have the dimensions of the holes on this. I would need to get that. So I'm just going to show you what they would be and make up some dimensions on this as we go here. So we start, I want to use the mirror tool with this just to show you how this works. And in order to do that, I need to take pick a plane. And so I'm going to show you how to use a construction line as a mirror line. So we're going to come in here and we're going to do a few things in this sketch. First, I'm going to sketch on this plane. Make sure that I'm on the top face right here, right? And not like this bottom face here, because this is what we want to sketch on now. So I'm going to click on this, right? Phase of extrude one. Again, I'm going to recenter this because it's not where I want it. Control, right click and drag and hit in for normal two. Okay, now to make a construction lines are not sketches. They're just like lines that help you do measurements and things like that. I'm not quite sure how to describe it, but you can make a construction, circle, rectangle, anything you want can be a construction. I'm going to click the line tool and I'm going to toggle it to a construction line. So you'll notice these are both highlighted. That's showing me that I have a construction line that I'm using. And I'm going to go snap this to the center. So click on the center. I'm going to drag up and make sure that it continues to be perpendicular to my edges there. And then I'm going to drag down. So basically I've made this construction line and I'm going to hit escape to escape that tool. So now I have this line here that I can use for symmetry. I also could have done this using the right plane, because the right plane is right along that construction line. So I could have used that as well. You'll see what I mean in just a minute. But I like using construction lines for a lot of things, and this was a good place to show you how to do it. Okay, so I need to make 4 holes. 1, 2, 3, 4. I would get some measurements on that. But because I'm not sure what the measurements are, I'm not going to look that up right now. I'm going to create another construction line. So I'm going to click line and then turn it to construction. And I want those, let's say that those screw holes are right in the center of this tab, which they aren't, but let's say they are. So how do I know if I'm in the center here? First, I can come to this line, and when I hover over it, when I get to the middle box here, all right, that shows me I'm in the center. And I can draw this construction line over, and you'll see I'm in the center here. So now I have a construction line where I know my center is, and I'm going to escape that, and then I'm going to turn that on again, actually. And I'm going to find the midpoint of this line, and I'm going to make another construction line. What that's going to let me do is keep my holes centered on each other, right? And again, I know some of you are going, there's a better way to do that, Dana Howard, and that's okay. I am just showing you a few of the things that I know. So we're going to use a center point circle here, center point. And if you're wondering why we drew this line, we'll come back to that in just a second. So I'm going to go create my circle here, and I would measure the specs on this, but let's just say it is around a 1.5 millimeter hole. So I'm going to type in 1.5 after I do that. Make the same circle down here. So I'm still on my center point circle. All right. And make that 1.5. Let me get my dimension tool. Let's say each of them are 3.5 millimeters. Okay, so I'm going to dimension that one, and then I'm going to dimension this one. All right, 3.5. So now since I've snapped the center of these to my construction line, those center of those circles are always going to be in line with each other across this line, this construction line that I created. Okay, now that I have that, now I can show you the mirror tool. So we're going to come up here to mirror, and mirror lets us basically create sketches and parts and mirror them across a line. So I'm going to click mirror. It's asking me to select a mirror line. And so the line I want to mirror across is going to be this one right here. And what do I want to mirror? I want to mirror this, and I want to mirror this. So all I'm doing is clicking on those. Now what I've done is, instead of drawing everything over here because it's symmetrical, mirroring just mirrors across this line, and dimensions are all exactly the same. Okay, so when I accept this now, I've got those holes, and I can come in and extrude remove these. So we're going to go ahead and remove, and we'll just click on each of these, all of these holes, and we're going to go through all. Okay. All right, so now my holes go all the way through. All right. And these are perfectly symmetrical with each other. Now let's say, oh darn, okay, my measurement was off. Now the nice thing about mirroring is if I come in here and I change, watch this, let's say actually this was 4 millimeters and I goofed up. So I do 4. Okay, that changed this one as well because the mirror is still there. And I can change this one too. Okay, 4, and watch what this one does. Okay, it jumped down 2. So when you go back in and change your dimensions here, it's going to change the dimensions there. The same thing would be true if I needed to change this. Maybe this hole was, I don't know, 1.8 millimeters. Okay, I don't know if we're going to know much of a difference here. But when I click on that, right, it's going to change this one as well because these were the same. So 1.8, and it changes both of them. So mirroring is really handy. Anytime you have symmetry, mirroring is super handy. All right, we've created our servo mount. Remember, we've used a couple of new tools, the shell feature. We have used mirroring and construction lines, and we've also used face splints. So keep learning all of these new skills. Hopefully this taught you a few new things, and we'll continue to make some more videos with some more advanced skills moving forward. Thanks for watching.